Good afternoon, everybody. This is Jeff Perkins. I'm the CMO of QASymphony, and we're very excited today to have a really excellent webinar, Test Estimation Hacks, Tips, Tricks, and Tools, featuring Matt Heusser and Justin Rohrman from Exelon Development. So before we get started, I just want to run through a couple things here. So these tips will help you get the most out of your viewing experience for this webinar. The audio for the webinar is delivered through your computer. So I've already got a couple of questions about how do I dial in. There's no dial-in. Just turn up your computer speakers and or use a set of headphones, and you will be able to access the audio. If your audio for this webinar is choppy, it's probably your internet connection. I'm talking through a phone. Our presenters are talking through a phone. So what we recommend usually is either to hardwire in or get closer to a place near your wireless router. That'll improve your experience. You are able to kind of customize the viewing experience for the webinar. You can see the presentation, a resources widget, a Q&A widget. You can feel free to resize those, move those around your screen to kind of create the experience you want for the webinar. If you want a bigger slides, you could just stretch that widget where the presentation is to make that bigger, so feel free to play around with that. Oftentimes I will either increase or decrease the size of my browser window if I want to see more of the presentation or less. So really make the presentation the way you want it. And if you have questions, we're going to be taking Q&A throughout the webinar. There is a Q&A widget on the lower right of your screen. You should be able to see that, so make sure to submit all of your questions in the Q&A widget, and we'll get to as many as we can before the end of the webinar. A couple other things I just wanted to cover off. One is who we are. So like I said in the beginning, I work for QASymphony. We are a company that makes agile testing tools, really built for teams that are doing a lot of test case management and exploratory testing. So if you want to learn more about our solutions, please visit QASymphony.com to get kind of more information about who we are and what we do. I also wanted to highlight an upcoming webinar on next Wednesday, April 27th. We have really a great session on agile transformation, people, process, and tools to make your transformation successful. We will be speaking with one of our partners from ClearVision. So if you're thinking about agile transformation, you're in the middle of an agile transformation, or you've gone fully agile but you still need to think about process and tools, please join this webinar. And if you look on your screen in the upper right, there is a what we call a resources widget. There's a link right there to register for the webinar. So even before this webinar is over, you can go in and register for our next webinar. So I encourage you to do that. For those of you in this webinar who will be at Star East coming up May 4th and 5th in Orlando, I would encourage you to stop by the QASymphony booth. We will be there. It should be a great event. If you are one of those people and you like to really schedule out your meetings ahead of time, I'm going to put there's a link right here for in the resources tab to schedule an appointment at Star East for us. So you can just go in there, and if you want to pick a 15 or 30-minute time slot, please do, and we'll set aside time so we can make sure we meet with you at Star East. I'd also encourage you to check out Mike Cooper's presentation. That's going to be at 3 p.m. on Thursday, May 5th. He's going to be talking about how to evolve your processes to work within today's fast-paced agile environment. So that'll be a great session. And Mike Cooper is one of our Board of Advisor members. So please stop by his presentation if you are there. So with that, I'm going to introduce briefly our two presenters. We're very lucky today to have with us Matt Heusser. He's the Principal Consultant at Exelon Development as the Managing Director there. Matt consults, trains, and contributes on software projects. He's probably best known for his writing. Matt is the lead editor of How to Reduce the Cost of Software Testing. He's the editor for StickyMinds.com and the recipient of the 2015 Most Popular Online Contributor to Agile at the Agile Awards. His partner is Justin Rohrman, the Senior Consultant for Exelon Development. Justin has been a professional software tester in various capacities since 2005. In his current role, Justin is a consulting software tester and writer working with Exelon Development. outside of his work, he currently serves on the board for the Association for Software Testing as the president. And so I want to thank both of them for being with us today. Really, really outstanding presenters to join us. A few more housekeeping items, and then we will hand it over to Matt and Justin. This webinar will be recorded and available on demand tomorrow. You will get an email from us when it's available. So don't worry if you have to drop out halfway through, or if you have colleagues that you want to share this webinar with. It will be available on demand. We are going to be live tweeting during the webinar, so please join the conversation on Twitter at the #TestEstimation. I, again, encourage you to use the question and answer widget. And stick around to the end of the webinar. There's going to be a brief survey. Just get your take on the webinar, and we'd love to just get as much feedback as we can, and that helps us figure out what to do differently in future webinars. So with that, I'm going to hand it over now to our guests of honor today, Matt and Justin. Take it away, guys.
Thanks, Jeff. Can everybody hear me? Or can Justin hear me?
I can hear you fine. Yep.
Fantastic. Good afternoon, Justin. We're fine on doing it. So let's get started. The picture is probably the #1 most shared, commonly known Dilbert that I've seen in the software space. And it's where the boss asks for an estimate but already has something in the back of his mind. And Dilbert says, why even bother asking me? Well, I want you to feel like you had input. I didn't know input was supposed to feel this bad. And the first time this happened to me, I was 20 years old on my first job, at my first big meeting with my manager and the client. We were developing software for a telecommunications company. And I knew it was going to take a month. I knew it. There's no way it could be done any faster. I had experience on my side. And I walked into that meeting, and I walked out having committed to do it in 2 weeks. And I actually did not know what had happened. I was I was almost shell-shocked with that experience. It's almost like negotiating for a car where you're negotiating on price, but I'd actually been negotiated down to a date that I couldn't possibly deliver, and the results of that were both tragic and hilarious. And I don't think that's just me. What do you think, Justin?
Yeah, my first venture into estimation was kind of similar. I went into a planning session, and there was a group of testers and one developer, and I had never seen the feature before in my life. And the developer asked how long I thought it would take me to test. And I said, I don't know, 6 hours. And then he shook his head and said, no, it's probably going to take 8. So I said, okay, and that was the estimation meeting.
So you were asked for input, and we call them the hippos, the highest paid person in the room, right? They tend to just, so what just happened? We want to do better than that. We'll talk about how to do better than that at multiple levels, primarily as the tester or test lead, but also from a test management perspective. So what I want to do today is make your life better by helping you answer how long it will take in a way that will stick. And to do that, I want to cover why. Like, why do we even need to do this at all? And then why it's significantly harder in testing than it might be for other activities. And a bunch of different ways to come up with estimates, when to know when you're actually in a negotiation, and what to do when that happens. That's kind of the agenda today. And we will take Q&A at the end. Usually, this is the part where I would look in people's eyes and ask if there are any questions. But I guess if you're confused, go ahead and ask on the Q&A, and Jeff can bubble that up to us and get a message to us. But that's the agenda today. Let's get going. And we'll start with How does estimation work at your company? This is a poll. So it's just a scale of 1 to 10, where 1 being it's crazy and people have unrealistic expectations, and 10 is we made logical decisions that are realistic based on data and account for risk. How do you think you do for test estimation? I'm really interested in seeing how these scores turn out. And I think we'll give you about a minute to do that. So let me ask you, Justin, if you were doing this, what's a 5?
A 5? Maybe you're doing estimates and you occasionally hit them, like 50% of the time or more.
Well, wouldn't that be
doing estimates. What's that?
So you would think that a 10 would be accurate prediction. That's really interesting.
Yeah,
right?
A 10 is doing estimates and doing them correct plus or minus a tiny bit every feature, every release.
Yeah, so it's unlikely. If someone were to come to me, you'll notice the word mature is in there. So if someone were to come to me and say, vague bullet point, how long will it take? I want to know within 5 minutes. So is it going to be October 31st at 5 p.m. or could you have it done by 4 p.m.? Like, that's not a mature question, right? So a 10 would have to be a logical process where we actually know what we're talking about and know how big it is and have boundaries that are reasonable, right?
So what would you call a 5?
5 is we're hit or miss. We try to circle around it, and the boundaries are not quite reasonable. Sometimes we're a little too early, sometimes we're a little too late. And then realistically for most companies, we're always a little too late, right?
Yeah, I think so.
Kind of thing where we say,
check on those poll results.
Yeah, let's do that. All right, so somebody said 10. That's interesting. And the average is around 7. So hopefully what we'll do today is give you, if the average is around 7, we're going to give you a couple of tools to take things to just one step better. I think would probably be a fair plan for the day. Let's get started. Why even do estimates at all? We go to conferences, talk to clients, do surveys. There's 4 common answers to the question of why we have to do estimates. One being schedule control. We want to know if we're in control or out of control. If we don't have a schedule, the time it takes tends to expand to take the amount of time that we're given. So we've got to create. This is almost psychological. We've got to create a deadline to create the activity to get done on time. Similarly, is cost control. So if we have a deadline, we can, even if this is what people tell us. I'm not excited about it. If we have a deadline, that we can't start the next project until that one finishes. So if we can have as aggressive deadline as possible, we can start the next one as soon as possible, control the cost of the project by controlling the schedule. Comparison shopping, which I think sounds the most reasonable, which is we have 8 different projects, and I don't know which one to start. We can kind of assess their value, but we need to assess their cost to figure out the ROI, right? Like I wouldn't buy a car unless I knew how much it cost me. I wouldn't just start making payments of $400 a month and never know when I was going to stop making payments. The final reason, and perhaps the most nebulous, is governance. So if you look it up in a dictionary, governance is actually the methods by which the people who are legally responsible for the corporation decide and manage what gets done. So we would be providing these estimates to help make decisions. I'm missing anything there, Justin?
One more. What's that?
Go ahead.
I just thought of one more reason that's actually not on the slide, and it's kind of meta. So another benefit is that it helps you to better understand what you're building. You can't make estimates without, to some degree, breaking down the work into pieces and thinking about what you're actually going to have to do to accomplish those goals. So in the process of estimating, you get a small plan in your head for what's going to be built or what's going to be tested.
Yeah, I could argue both sides of that, but I see the argument where someone says, how long will this take? Well, I have to define what it is first, so let's break it down and answer it drives out a bunch of questions early in the process that might not otherwise get asked till later, which would mean fixing and retesting because we made the wrong decision. I understand that. So what we're going to do today, so there's a whole movement called no estimates that pushes back against these and says these reasons are silly and cause dysfunction. What we're going to do today is we're going to embrace the premise and try to answer the question well, just like we did for the reducing the cost of testing book. There's a place for that questioning, but we're not going to cover it in the webinar today. Before we get to the methods, I want to spend a minute talking about why this is much more challenging with testing than in other activities. Most projects are linear. There are 15 things you have to do. When you've done all 15 of them, then you're done. And testing doesn't work that way. I think Justin has some commentary on that he wanted to share.
Yeah, so if you look at the actual work in testing, a lot of that isn't spent either hands on a keyboard and mouse or in the IDE testing software. There's a lot of work that wraps around it. So there's an acronym that I've heard, I forget where it comes from, that describes the work a little better, T, B, and S. So you have test time, which is the amount of time you are actually testing the software. B is for bugs. That's all of the follow-up testing you have to do around a bug and the time it takes to report. And then S is setup, which is all of the work you have to do in order to get to the stage where you can test. But even that doesn't really accurately describe what's happening because there's also meetings, there's waiting around for bug fixes and builds, there's talking to developers and trying to understand what you're going to test. There's a ton of work that wraps around the work of a software tester that we don't talk about and we don't really have good visualization on.
Yeah, the T and BS, and I want to do more T and less BS. John Bach has some papers on that if you want to search for that. And similarly, the image at right at the top is derived from some of his work. So you see at the top right, there should be 40 hours. That's straight. So if I was just testing and I needed to get coverage, and then there's a big application and a bunch of browsers and a bunch of devices, and we're going to invest 40 hours of work into it. If I find no problems, I could do it all in 40 hours. But top line is what actually happens. We make a little bit of forward progress. It's not straightforward. I've got to go to meetings. I've got to check my email. I've got to do support requests. I've got to do other things. And then I hit a bug. And my left to right motion stops. And I start doing this up and down motion, which is I've got to see if that's a real problem. Did I misunderstand something? Is that a symptom or is that a root cause? Is there a deeper root cause somewhere else? So I test around it. Then I want to figure out how to reproduce it in very clear ways. Then I have to document what it was. Then I have to possibly, if it's a blocker, if the login is broken, I'm stuck. I probably have to argue whether or not it's a bug. I probably have to show the developer how to reproduce it, unless I had a tool that allows me to capture video, like our host QASymphony tool does that. But either way, there's a lot of waiting in here. And then finally I get to make forward progress once I've got a new build. But I might actually, you see a few places in there, make backward progress because now I've got to retest the areas that might be impacted by this change. So the actual time it takes linear time, calendar time, 160 person hours, 2.5 weeks. What should, in air quotes, take 40 hours. And that's a lot of that is due to things beyond the tester's control. The quality of the software before it gets tested, the amount of time we're waiting for fixes. Out of 100 changes, the number of changes that will introduce another bug, the percentage, recidivism rate, which is the percentage that we get new bugs due to a change. And then those need to be retested, and then those need to be retested. Could actually be a significantly different amount of work.
Otherwise known as failure demand, right? Work we have to do because something didn't go right the first time.
Yep. And I say non-linear because not only is it not straightforward, like we plan 40 hours of work, but it takes us 60, we actually can go backwards, right? So the second image there is a projection. And the squirrely lines are the actual amount of the work. And what I did was I drew a line from the top left through the second curve and then extended it out. The difference between the first line and the second line is the difference between the plan and reality. And what we can do is actually project based on performance, and we're going to talk about that later. That has to take into account these things like we're going to have to rerun tests. We're going to have to do all of this triage and documenting and retesting work. We're going to have all this waiting involved.
Wait for new builds, wait for bug fixes.
Oh, the next slide, we're going to have an exercise. You will need a piece of paper and a pen. If you're really lazy, you could probably use Excel. So you're probably going to want to start looking for that now. Well, let's get into the nitty-gritty. Now that we've talked about the problems with estimating, let's talk about how to do it anyway, right? And the first method, which is probably the most commonly understood, Jeff alluded to it in our introduction. I think Justin mentioned it. Justin mentioned it on the second earlier. Is functional decomposition, which is a fancy way of saying, let's take all the work out, break it down into small chunks, estimate all the small chunks, and then add it back up again. So we have an exercise that simulates this, that if you're listening to this alone, you can do with your team. That gives us a feel for just how hard this really is. So hopefully by now you have your piece of paper and a pen. What we'd like to do is we're going to estimate our height. So the first thing you have to do is forget all you know about your height. Pretend you don't know it. Please don't do any reverse engineering where you know how tall you are, so you change the size of your head so that it matches up to be right. Please play this exercise straight with me. What I'd like you to do is, pencil in hand, we're going to estimate each part of our body as I tell you to. So start with, you can use inches or centimeters. Measure your height from the bottom of your foot to the top of your shoe. If you're not wearing shoes, I suppose you can use the top of your ankle. We'll give folks 10 seconds for that. I don't think that's that hard. You might not have a pencil yet. Okay. Now estimate from the top of your shoe to the middle of your knee. All right, and percentage-wise, this is way more time for a way easier task than we typically get when we get to do estimation like this. Now measure top of the knee to about the top of your belt. Okay, now top of the belt to the bottom of your shoulder with your shoulders slumped down. And there's a reason for that. Top of your belt, bottom of your shoulder, shoulders slumped down. Now we're going to estimate bottom of the shoulder, that's shoulder to chin with the chin up. Please don't get a ruler and try this. Just estimate it. Just eyeball. Bottom of the shoulder with shoulder slumped, the bottom of the chin with the chin up. Okay? We're only going to measure 6 things, 6 numbers. Are you following along, Justin?
Yep, I am. I've got my pen and paper right here.
Okay, great. We'll use you you tell me if I'm going too fast. Now do the bottom of the chin, top of the head. Okay, now add all those numbers up and compare to your actual height. How's it going?
I was way off on mine.
How far?
I came out, so I did my estimates in inches and came out to be 7 feet tall, 7'6".
And how tall are you actually?
I'm about 5'10", 5'9".
Okay. We did not prepare this beforehand. When I did this last night in Grand Rapids, the average was about 10% off. But think about that, 6 numbers for something physical and tangible that you can look at, that you've seen, that you've known for, since you were probably 17 years old, you stopped growing. I compare that to the complexity of a real software project. This approach is pretty naive. Now the hope is we're going to be off on some things and under on some things and over on others. It's going to average out. It typically doesn't happen. You typically get exactly what Justin saw, where you're way too high or you're way too low. But yet, people understand this. People have been grown up with Gantt charts, and this is expected. So it's super easy to sell. Everyone understands it. And there's even a game that is very common where you put your padding into it, and then your manager takes it out, and you end up about where you started, and maybe you'll be okay. I think that life is too
game, right? That's what you're talking about.
Yeah. And I think life is too short to play games. That is ridiculous. I don't know the last time I estimated a project this way. I can't remember it. It's been years, and yet I'm still doing okay. Actually, I think we've got a couple of projects that we did with very, very, very well-known deliverables where we estimated in dollars. But as a business owner, that means that if we're late, that's just my cost. It's a little different than estimating in hours, right? Let's get past that. Method number 2, breadbox analysis, comparison. You've probably heard this said. I'm just trying to get a feel for this project. Is it bigger than a breadbox? Is it bigger than a fire truck? Like, is this a quarter? Is this a month? Is this a week? Is this a day? I don't know. Usually from a non-technical person, right? And we could.
Yeah, it's like the agile mouse, horse, elephant estimation.
I think I've heard that one before. Yeah. So I want to take that away from time and say project. Let's make a list of our last 10 projects. Sort them by complexity. and say it's somewhere between these two, right? Maybe our last 5. If we have accurate data about those projects, so we really knew how much it costs, and that's where we get in trouble, because our visibility for test is when the hot and heavy testing started, and not when actually test was involved a whole lot more upfront and a whole lot more toward the end, but we forgot about the patching and we forget about the upfront stuff. So we have accurate data. And the technology doesn't change much. And the team doesn't change much. And the subject matter doesn't change much. This can be a very, very effective and cheap way of estimating. But the problem is when things change. So the picture is of a meerkat among meerkats. This is not the same thing, right? So it's fast. It can be pretty accurate. But it's also risky because there aren't a lot of companies that I work with that have accurate data. In fact, some of the ones that think they have accurate data, we actually change the time allotted and steal from Peter to pay Paul to make it look like it's right. And if you do that, your next project estimates are not going to be based on good data. But man, it can be a fast way to do comparison. It can also shift the onus, right? So when someone says, I want to know in minutes how long this will take you, you say, well, it seems like this feature here is between those 2 features. And then the person who's doing the asking has to go get the data, and now they're in it with you instead of being able to blame you, right? Does that make sense to you, Justin?
Yeah, I think so. When you say steal from Peter to pay Paul, can you clarify that a little bit for me? Are you talking about like borrowing resources from other departments to get it done faster than you thought you could?
I'll be very specific. You're estimating tasks in hours in JIRA, and you have 40 hours per week, and this task is supposed to be 5 hours. So it really takes you 7, but you have a bucket for administrative time for the week. So you take out of the bucket for administrative time, and so you report 5 hours of the task and 8 hours of admin, when really it was the other way around. You actually falsely report how you spend your time to make it look right.
Okay, I see. So you're doing a little budgeting artistry on the backside.
Yeah, which throws off any kind of future plans. Right? Which brings me to my favorite method of estimating, and that's time-boxed. How long will it take you to test if it has to be done by noon? Till noon, right? And this isn't necessarily bad. I can spiral outward, working from the most highest priority to the lowest. If we can agree on what those priorities are, and stop whenever you want me to stop. It makes the decision super easy, and we don't spend a lot of time arguing about how long things will take.
So you're saying if you have a known time box, we can produce a list of all of the things that need to be tested and approximation of how important they are, and then let somebody make decisions of, 1, is that time box okay for us, and 2, are these really the things we want to test?
Well, the simplest way, if they trust us and we're investing in risk mitigation and we want to invest 1 day in risk management, we make a list of our risks, and we go through those risks until we run out of time. That's it. What you're talking about, we're going to cover a little bit later, where we get a little more sophisticated. But if you just want me to test for a day, I could test for a day. Now, at the end of that day, I might say, these are the risks that are uncovered still. Or at the end of that day, can you test for a day? Sure. And at the end of that day, I might have 8 showstoppers. So saying we're going to test for a day doesn't guarantee.
You just get what you get.
Right. Doesn't guarantee that we're going to get done. The problem with this is, as you point out, the lack of transparency. Right? So we could have, why didn't you find that bug? Well, I only had 8 hours. Well, why didn't you test for that bug? Well, You might have an awkward conversation. We're going to talk about how to get around that in a minute. I mentioned the nonlinearity before. Not linear. Again, we might go backwards. We might go, things might take longer. We might be waiting for, but typically if we're waiting for builds a lot, if we're waiting for the environment, if we're waiting for a deviated grant access to a table, to some extent that's going to be predictable. Out of 40 hours, we're waiting 7. Probably not going to change much. And the recidivism rate might have some amount of predictability if we have the same team. So if we have our planned work and we count how much we actually got done in a time period, in a day, one of the companies we work with out of Oregon, they had why does regression testing always take so long? And they had their test ideas planned in 5-minute increments. We said, okay, fine. So what's the day? A day is 60 times 8 hours divided by 5 minutes apiece. You should get so much done. Well, count how much you actually get done that first day, and then reproject, assuming that velocity, how long it's going to take you. And they got reasonably accurate estimates that way, right? So this example is from an actual client. It's a simplified and modified, and we took all of the customer data out of it, but it's from an actual, the source is an actual client system. And originally it was, you had one section, and then that section would have 3 or 4, 5, 6 different items in it. We put the section on everything. We add a priority and an effort, and then we sum all of the efforts all the way down. And we sort by priority. So if you can see this, if you can zoom in, this is from an e-commerce project. So priority 1 is all path to purchase. So first thing they see, can they log in? Can they add to cart? Can they search? Can they check out? But then priority 2 is below that, priority 3, an effort. And we can sort by priority. So if we're counting, say we do, I don't know, we want to ship it tomorrow, one day. And we have, we figure we can get 150 points done in a day, right? So we say, okay, well, we're going to just test with 3 major browsers. We're going to do Chrome, IE, and Safari on a tablet device. So we probably have about 150 points to spend. So we could go to the cut line. The cut line is right around 50. So user can click color on item on category page. We're probably going to get to about there for everything. Now, do we want to put more energy into IE, test Microsoft Edge this time? Do we want to just test everything to the 50? And we can actually reflect this back to management and say, based on our historical trends, we're going to get to about here. So that means that we're not going to have time for these risks at the bottom. And typically, we get a little bit of hemming and hawing there, right? Like, gee, I don't know. So you test all day, and then you find some bugs. And you can come back and say, well, this is how far we got. This is what's left untested. These are the bugs we found. Okay, well, still ship anyway. Okay, so we had risks at the top above the cut line materialize, and we decided to risk shipping anyway. So do the things below the cut line matter? And that is a very different conversation than is ready to go, yeah, I need more time. We want to avoid these sort of yes, no, silly arguments, and instead materialize the risk and make a shared decision about the risks that are left that we don't have time for. I like to say that if you're a really good tester, you will have more test ideas than you have time. A customer once said you should test everything. I told him that you will never be able to ship the software. I can guarantee I can keep you testing forever. happily billing, but not really adding business value beyond some point. So prediction, it's accurate, it's sensible, based on data, but it does take a little bit of work to set up, and you need to have a receptive audience. They need to be able to understand it. And you do need, things change too much, it won't make any sense. If you outsource it all of a sudden to a team that vastly makes the bug injection rate worse, your data is not going to be any good. There's also a problem that it tends to focus us on the lines in the checklist. It tends to become a checklist approach. Somebody else made this census of risks, or I helped make the census of risks yesterday, and now I'm just going to crank through them without thinking about new ideas, emergent risk, or balancing the quality of the work. And that hurts your creativity. So there are these things called black swan risks based on Talib's book, The Black Swan. And psychologically, unless we're very careful, if we're super focused on hitting our predictions, we can get blinders on our testing, just like any other time that we're super focused on hitting a deadline.
So can I talk real quick about what a black swan is for those that haven't heard that term before?
Please.
Okay, so around the 1500s, if you saw a large, pretty white bird with a nasty temperament, you were going to call that thing a swan. If it was a different size or a different color, it was no longer a swan. So the British sea power were becoming larger and traveling the world when they got to Australia. And they discovered a large, pretty black bird with a nasty temperament. And they discovered that this was also a swan. It was this shocking event that changed their worldview. And whenever we get into testing specifically on checklists, basically you test this thing, then you test that thing, then you test the next thing, you reduce the chances of running into those surprising events. And that can sometimes turn into bugs in production. So you're reducing your exposure to those things and increasing the chances that somebody else will discover it, probably a customer.
Yeah, so in the financial markets, Talib was talking about, the black swans were things like the subprime credit market, where they gave all of these loans to people with poor credit, bad credit, no jobs, because it doesn't matter, because if they have to foreclose on the house, they can just sell it, because housing prices always go up, because there's all this data that housing prices have gone up for the past 40 years. But all of a sudden, there was a ton of foreclosures all at the same time, which increases the supply of the houses on the market, and housing prices went down, and we had this horrible credit wipeout, bailout situation. In hindsight, it looks really obvious, but for some reason, we can't see it in foresight. And I tend to call, when those things happen in software, I tend to call those black swan bugs.
Like the Knight Capital bug, another finance example. They had a software bug that caused them to lose like $4 million in one day. It surprised a few people. That was a black swan.
I thought it was just like 400 million in an hour, and it was a high frequency trading. It was a simulator designed for testing that accidentally got leached into production. At least that's the.
It was a lot of money that almost put them out of business.
Yeah. Yeah, and the speculation anyway, that it was a test system designed to inject lots of changes in the market that accidentally got out. Next method to estimate, the guru method. Pick a guru and we ask them for a date. Right? Now, what's actually happening with the guru method probably is the person internally is using some of these other things we're talking about. That's what's really going to go on. They're using their own past experience. They're comparing it to prior projects. They're looking at the team. They're thinking about the recidivism rate. They're thinking about what management could accept as a date. Rapid Development by McConnell has an actual example of this, where they asked for a team. They asked a bunch of people for their estimate, and the one person who had worked on the system before gave a ridiculously high number, and he was right. So the problem with the guru method is it's not transparent. You don't know where the numbers come from. People have accountability, but that should be shared. You need to understand
the question of which guru you pick. The person with the main expertise, or the person with technical expertise, or just the person that's been there for 10 years. Like, each person is going to have different perspectives on the work.
But really, this is some other kind of method that is completely hidden and opaque, and you don't know what's going on, and you hope that person is good, and if not, you blame them. And I just can't make my business decisions that way. I don't know about yours. So a little better than the guru method is we get several gurus together and we average the results. The thing about that, there's something, it's got a fancy name. It's called wideband Delphi. Every time I read that, I'm upset, because all that means is get a bunch of people, take their estimates, average them, throw out the high and the low, and average them. When I see a high or low that is remarkably outside normal, I want to explore that. Tell me why and where that number came from, instead of just throwing it out. So getting everybody together, getting consensus, working with the team. James Surecki wrote The Wisdom of Crowds. He actually did some research, and he found that if you have one of these games with you're in a life raft and you have to pick 10 items to go into life raft to see if you can survive a week, or you're stranded on a desert island. Teams who took a democratic approach and just voted an average actually did better than teams that had a single strong leader deciding. The only exception would be if it was, say, the life raft problem, and maybe the strong leader was a Navy SEAL or something. Generally speaking, there's an incredible amount of power there. I find in corporate America it's hard to do. People get very uncomfortable. There's a lot of learned helplessness. It doesn't matter what we say. Management's going to do what management's going to do kind of behaviors. Trying to feel out the number, political games. Right? So what I recommend is do all of them. Get all of them. There's an idea in search and rescue called triangulation, where you go to three or four different locations and you get a direction finding reading. You plot that on a map, and where those lines intersect is probably going to be pretty darn close. So if we use a couple of different methods here, we'll get a couple of different numbers. That can give us a range for our estimates, and we can defend it. The problem with it, it's going to take a long time. People might not be willing to wait. We're spending a lot of time estimating and not much time testing. I really want to be sensitive to that. So what I'm saying is gather data and build your own models for project performance. You've got to learn to work with people, get them to ask us questions. In this setting, I get to lecture. It's fantastic. People want to hear what I have to say, and I can just say it. But in a business setting, when I try, unless I'm invited, when I try assumption, 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 logical transformation, conclusion, you have to agree with my logic, that conversation often goes very poorly. So here's my data, conclusion, and then how did you get that? Oh, let me explain it to you. You've got to have more back and forth. All right, so this actually happened very recently with one of our contractors who was really struggling and said, Matt, I'm behind. How can you possibly be behind? It started very recently. How can you be behind? You're only on the project for, I'm going to make some numbers up. You've only been on the project for a month. How could you possibly be 3 months behind? Right? And it was behind before she got there. And even if we made testing free on that project, even if we press a button, get instant test results, bam, magical, faster than automation, those test results would include bugs. Those bugs would need to be fixed. We would need to wait for a new build. We'd press the button again, and then we'd have to wait again. Then the project would still be late. So testing wasn't the bottleneck on the project. Or if it was, there was a greater constraint, which was the actual fixing. So if that happens to you, get the data. Right? So you could say, I'm spending this much time fixing, I'm spending this much time on bugs, this much time on setup, and this much waiting. And then we can figure out whether the problem is the waiting or not. Having that data will help us explain why, wait a minute, you should be able to do this tomorrow. Why do you think it's going to take all week? Because we're going to need to wait for 3 more builds. Right? Let's go back to that first job, that first interview. If I had said, here's the work, here's my progress to date, here's how long it takes me to build a feature. Oh, you want it in 2 weeks? And I was building an electronic audit, which is kind of like test automation against the telecommunications bill. I was building a system to compare the pricing in the bill to a different model to see if they matched. So, well, based on performance so far, this is what I could get done in 2 weeks, right? It's like, well, we want you to get done more. Oh. That's what the projection is showing. Now I could say, but if you gave me a month, I could do all these things. If you wanted in 2 weeks, I can give you this. If you want, we split the difference, we could get to here in 3 weeks. That's a very different conversation. It's transparent. It's based on performance. Well, Joe thinks he can do it in 2 weeks. Okay, great. Let's give the spreadsheet to Joe and see how long he can see his progress. There wasn't anybody else because I was the subject matter expert at that point. They'd already invested some time in me learning the system and me learning all of the, starting to write the code. Anybody else would be starting off on square one. Nobody could do it any faster. We were playing a game. So what I'm suggesting is we get beyond yes and no. We stop playing a game. And we start talking about what we can do based on historical trends. One more piece to that. When we talk about estimates, we tend to talk about them in terms of October 31st at 4:54 p.m. and 30 seconds. Just way more precise than is realistic. Steve McConnell came up with this idea called the cone of uncertainty. There's a lot of criticism of it in the research. But the basic idea is that at the very beginning, we really don't know anything about performance. And it's a huge separation between the possibilities, how long things could take. And over time, as we know more, that'll come closer together. That cone will decrease. So when we talk about estimates, we can talk in terms of confidence. I'm not going to talk about standard deviation here. We don't have time for it. It's the end of the hour anyway. But what I'm trying to get at is we can say, wait a minute, you want an estimate. Do you want our most likely chance of making it? Or do you want our commitment to deliver? Do you want 50% confidence, most likely? Or do you want, based on past experiences, expecting things to go wrong, adding a little bit for risk? We can commit to 2 weeks based on what we know, right? There's a huge difference between that. You can say our 50% confidence is this number and our 90% confidence is that number, assuming we start right now, da-da-da-da. Now we're talking about a vector, distance and direction. Now we're talking about, and what management can do with that is they can crank the dial back. They can go, we want less risk, more time, or more 10% confidence, right? This is from DeMarco and Lister's book, Waltzing with Bears. They talk about the nano% date, which is typically when we give an estimate, that's if everything goes right. If I'm not called on any support calls, if everything goes fantastic, if all of our experiments succeed, if we get builds quickly and nothing is harder than we thought, they call it the nano% date because it's the first time the chance is anything less or anything greater than 0%. We're pretty good at coming up with the nano% date. We need to stop doing that because we will look like a bunch of liars. And start talking in terms of based on past performance. Here's the 40%, 50%, 90% confidence interval. Even if we do that informally, based on our own experience, I submit that is better than a single number. And if you really want to hear about it, we could talk about how to do the math some other time. Okay, I have introduced 6-7 different methods for coming up with estimates. I'm really curious what you folks are actually using. So if we could take 1 minute and let us know. So are you doing the guru method? Are you using the consensus method? Does someone just give you it should be, we need this tested by noon? Do we actually have comparison to similar projects? And I'm going to include with that, we release every 2 weeks, and it takes us about 3 days. We start testing Friday. We release on Monday. We know how long a sprint takes compared to other sprints. That'd be comparison. Are we doing prediction? Are we negotiating politically, or are we doing it based on realistic trade-offs? I think there might be a bug. I'm not sure. We'll see if you folks, and this is multiple. This is multiple click. So this is the checkbox. Do as many as you're actually doing, and we'll give a minute for that. I had a ton to cover. I'm sorry, we're at 3 o'clock Eastern already. Thank you for staying. Anything I missed, Justin, while we wait?
Well, we had a short amount of time to go through all this material, but I think we did a pretty good job. If I had to select one of these methods as my favorite, I'd have to say it's kind of a nuanced time box, where somebody tells me how much time I have, and I say, okay, I need to test these things, which is most important.
Yeah, I like to visualize. Like, let's do, and there are tools that can help you do this. If you've got data, I understand you may be able to use some of the features of QASymphony to do something like this. But even if it's just the sticky note, even if it's just sticky notes, here are all of our risks, right? How much time have we got? Okay, these are the risks. Is my order right? I might add things that I find later. Let's go. And you run those across the board from untested to doing to done. And then you come back every hour or every 4 hours and say, this is what's left. Can we make it? Can we ship? Or whatever the decision we're trying to make, right? Should we go do something else? We're doing continuous delivery. Have we done enough general testing and go focus on something else?
One other thing came to me too, and that's if you're spending time debating on the size of a task, whether a task is a 5 or an 8, or if it's small or medium, you should probably focus that energy elsewhere, like maybe on reducing this or breaking that task down further so that every piece of it is small. So
I like
stability.
I like tasks that are so small that have a modest amount of variation. We can just count the tasks and stop worrying about the multiplier. Yeah, absolutely. Let's go check it out. So about more than half people have relevant historical data. That is fantastic.
I wish we could see who clicked multiple options there to see who is stacking their estimation techniques.
Right, yeah, and what those multiple options were. Yeah. So maybe we can do a follow-up survey or something to kind of figure out the state of the industry and just how mature that comparison actually is, right? A lot of that is probably just we ship every 2 weeks. We're running really late, folks, but I think we covered most of it in the talk, right? We want to get an argument away from yes or no to be, here's what we can do if you give us this much time based on history. Do you care about the risks that are below the cut line, right? And is the order of risks right?
So do we have time to? Go ahead.
Well, I was just going to say that you could do that with very, very lightweight test cases. You could use charters for that. Lots of ways to do it. Could we take a question, Jeff? I know we ran over.
Yeah, we're a little bit over, but since this is available on demand, we may as well keep running. If people could stay, that's great. If not, they could watch some of the Q&A back on demand. So let's jump into some questions. The first one is about the relationship between the testing team and project management, and it's why is project management not satisfied when your estimates are exceeded because you have spent time on bug investigation reporting, retesting, etc. How should testing teams or testing leaders respond to the project management team in this situation?
Well, I think it's fair to say, gosh, we really were surprised by the things that were outside of our control. The quality was lower before it got to test, which means we had to do more of these activities. We're going to keep that into account next time. I think would be a reasonable way to do it. Yep. But, so it was out of our control. Or go ahead.
So a lot of the stuff comes back to reporting to other people, and I think we should assume that they have a very real need for the data. So it's not necessarily about getting in trouble for getting a wrong estimate. It's that project management needs to have some way of understanding approximately how long things will take so that they can do their job. So inviting them into that conversation about estimation probably gets you a little bit closer.
You got to realize the project manager, classical project manager, is very much focused on this kind of linear view of break all the work down into small chunks and add it up. They don't understand the going backward piece. They don't understand the documenting bugs piece. As far as they're concerned, that's all just testing. They just want a number. You gave them a number and you were wrong, right? So you can try over the long haul to invite them for coffee, to engage them. In this presentation, we gave 2 or 3 different examples of, here is our census of risks. Here is our list. You can see my hands are moving backward and forward like a expanding list based on time. But they don't see that. Right now, all they see is you gave me a number and you were over it, right? So here, if you're going to be in that space, if they don't want to so I'd buy them coffee and explain it to them and show them the cut line and show how we do all the work and try to change to a risk-based strategy. If you're only going to give us 2 days to do this testing, then we'll just adjust our testing backwards to hit that. Try to educate, try to build a relationship, and eventually get the data to say it's waiting for the fixes. That was beyond our control. But what we can do next time is build more allowance for more fixes into our estimates. That's how I do it. And I wouldn't make a habit of it. Now, what's going to happen there is next time your estimate's going to be bigger. And so why is this number so much bigger? Well, because the conversation we just had at the retrospective for the last project, that's why. And that's just an education process, and we can't be lectury. And I think Mr. Klain calls it smarty pants syndrome. We've got to find a way to come off as partners that are helping solve a problem. Best way I've done that is to reduce the scope of the testing to hit whatever our commitment is.
Great. Now we have a question specific about what should be included in the test estimate. This person wants to know, do you include time spent waiting and time spent reproducing? Is that to be included in the test estimate?
So it depends on who I'm talking to, but I would ask that question. I'd say, and I would inject an assertion and let them correct me. So it'd be like this. So I'm going to give you an estimate of how long things will take in calendar time. So if I say 2 weeks, that means the whole process should be 2 weeks. Now, there are some things there that are outside of my control. If I keep getting a bug bounce back to me that is in fact not fixed, there's nothing I can do about that. But that's what my estimate means. And people have to understand that that's what you have to get beyond the bullet point to be successful. But yeah, I typically would do the whole process. And that 2 weeks, so we get in trouble where 2 weeks, but I was 50% on one project and 50% on another project, and then I had my vacation, and then I was sick, and then right? So we've got. I tend to talk in calendar time, not effort, because effort gets me in trouble every time.
Some of the stuff is simply unpredictable too. If you get a new feature and you estimated originally it's going to take you 1 day, and the first build is dead on arrival, and immediately with the second build you find a bug that has to get fixed, and then the next build you get is like 4 p.m. I mean, you just can't do anything about that except for share the information with other people and let them know why the project is running late.
Yeah, another thing to look into is unplanned work. Why is this going to take you 2 weeks of calendar time? This is like a 3-day job, right? Yes, that's true. But I've been tracking unplanned work, and we're spending 70% of our time on it. That's support calls. That's trouble tickets. That's answering questions about a feature. That's going to meetings to plan the next release. That's providing estimates on the next 17 releases. So once you count the actual time that I'm going to be at my desk doing testing, it's going to be 2 weeks. And that's actually a good conversation to have. The best part of that conversation is when you say, but if you could get me out of these stupid meetings and get back to what I love doing, which is testing, then I could get it done for you faster.
Great. I'm going to ask 2 more questions. What I try to do is go through a couple questions and pull out things that multiple people ask. So the first is on scope. So how do you estimate the efforts for testing a project where you're unclear on the functionality, you don't really have a clear understanding of the scope? I mean, where do you start in building out your estimation?
Well, there's a couple of things in there. One is that cone of uncertainty is going to be really wide, right? So you might say, gosh, I don't know. This could be anywhere from a week to a month. And there's so many different kinds of projects, right? Like on an Agile project, these dates are not going to make sense. But I think the question is coming from a place like that. So we're just trying to, I had an actual company I worked with, we're trying to do electronic funds transfers. What's the entire delivery estimate? Well, we already did electronic funds transfers for our administrative services only. So it meant something much more nuanced. So I didn't, like, what is, I don't, I'm blah, 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 blah. So I could just give a really wide range. I could say the best way to do that is this kind of like name of other project in effort? It seems to me like it's similar to name of other project. Well, we could just use a wide range for that. How big was that project? So reframe it out of abstract bullet point that no one understands to something comparable that has recent memory and data behind it. You got any ideas, Justin? It's a tough question.
That is tough. Generally, where I would start with that is by talking with people. I'd go over to the product manager's desk, the person that understands the feature and the changes from a customer's point of view, and have them walk me through what the changes and what the value is that the customer is supposed to get from it. And then I'd go over to the developer's desk and get an understanding of what was going to happen from a technical perspective. And hopefully you can do that briefly. Maybe it takes like 30 minutes total, and it just gives you a more rounded view of what you're going to be working with.
That's a great example, because when I've done that, honestly, often no one has any idea. And you go to the developer, and he's like, I got asked the same question. Blah, 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 blah. And you ask the product owner, and they're like, I don't know, we're trying to ask these to figure out we don't even know what we're building yet, right? And that's great, because it means we're finally involved up front, just like we always wanted to be. We're finally at the strategy table, because we get to, we're so early in the process, we get to make trade-offs about what the thing is and what we're going to build. So if we do this, it would take this long. If we take that, it would take. It's a leadership opportunity, and testers squander it and walk around the smarty pants syndrome and tell everybody that they're dumb and don't know what they're doing. Right? No. Take a leadership role. Start talking about features. Help define what it is. The other thing you can do at that early in the process, we should have said this earlier, but we're running too fast. You can always say, let me get back to you on that. I'll get back to you on that in a week. And in that week, you can have the meetings with the dev, with the PO, lock yourself in a room, get some coffee, figure out what the heck this is, draw on a whiteboard, create a strategy table yourself, and come up with some dates. For that matter, ask for 2 weeks, get the dev, and prototype the dang thing. Right? That's the best, great way to create estimates. The pragmatic programmers call them tracer bullets, right? So you're actually, it's not just, it's a proof of concept on the technology side. So all we want to do is move a penny from here to there, and then access the databases to understand how EFT works. And we'll build all the other systems after. But if we spend those 2 weeks and we're spinning our wheels and we don't even understand how PayPal works yet, it's going to be a long time. And if we get the proof of concept done in 2 weeks, we'll have a really good idea of what the thing is. So there's a couple of things you can try.
Great. Last question was about on, more specific to team culture. And there were a couple of people who sent in questions around, well, my team doesn't like to deliver bad news, or my team, likes to please our, internal stakeholders. What do testing teams have to do from a culture perspective to improve in the test estimation process, so they can deliver bad news when necessary, they can give accurate estimates? What are some thoughts on team and culture?
You want to take that one, Justin, and I'll follow up.
Sure. So I've seen that happen a couple times where groups of people are scared to give bad news, or they're scared that the news will get the managers riled up or the leads angry with them. And they're almost always worried about what we call sock puppet management. They're just reporting up to a manager that has probably no clue about the details of the work. Like if you go to a lead, they're going to understand. If you go to a manager, they're going to understand a little bit less. And if you go to a director, they're not going to know about the details of testing, and you wouldn't expect them to, really. So in those situations, I like to ask, are these people actually going to get mad about the information you're giving them? Usually I find it hard to believe that that's the case.
Go ahead.
What would you say about that, Matt?
Well, a couple things occur to me. One is earlier I referenced his book, Waltzing with Bears, Managing Risk on Software Projects by DeMarco and Heusser. That really influenced me quite a bit when I read it. It was actually on the table at Star East in 2004, and I picked it up and I had it half read. I might have finished it on the plane on the way home. It's a fantastic book. And the quote that stuck with me from that book is, when it's better to be certain and wrong than to be uncertain and right in your culture, you're in trouble. Right? So it's better to say, yep, it's going to be, we're going to have it done in a month. Yep, we know it. We do it. And then the month comes, and the last day of the month they go, man, gee, there's showstoppers and features aren't built out yet. What a surprise. We're going to have it done in another month. We're sure of it. And then another month, same thing happens again. Because the culture rewards that confidence, it's time to have some really tough conversations. I mean, I might seriously consider buying that book and giving it to people for Christmas. Right? I don't do well in that environment. And you might want to ask, can I change the environment? Or should I change my employer, or should I change my employer? It's tough. When I was working at, had been a division of a Fortune 500 company, had been recently sold. And I remember a meeting where we were going to have the deal with reality meeting with our manager. We're not going to hit the deadline. We came in and told him this. And his head sort of went down, and his expression got very sad, and he was going to have to report this back, and everybody felt really sad for him. And we started saying, well, if everything goes well, and if this happens and that happens, and maybe we can combine these two features and we can cut this. We left the room committed to the date. We walked into the room. It was the same thing from that first meeting when I was 20. We walked in, we're going to tell the truth. We walked out, we didn't tell the truth. The senior developer on the team actually said, well, our manager heard what he wanted to hear. That's his fault. We told him the truth, and that's his. It really didn't feel that way. We were complicit in the untruth. So I went to my manager the next day in our one-on-one, said, we're not going to hit the date. It's not going to happen. And again, with the puppy dog look. And he said, how do you know this? I said, well, maybe you were in the meeting yesterday, but I've been hanging out in the bathroom, and I overhear people, and everybody knows we're not going to hit the date. So let's talk about reality. And to become, I think in that environment, if you can find the right leader and become the positive, trusted advisor who speaks the truth, even if people don't want to hear it, in a positive way, because it's better to know than to be surprised the day before the end of the month. In my experience, that has been rewarded. I've done okay. So that's what I would do if I was stuck in that situation. Find someone who will listen. Tell them the truth in a positive way. Great.
Well, Matt and Justin, I want to thank you guys for your time. We have more questions. We'll try to do a blog post and answer some of the questions we didn't get to. So check our blog. There's going to be a survey coming up once the webinar ends. So if you have a second, it's just a quick 5-question survey. Please take that survey. Let us know what you thought about the webinar. And Matt and Justin, do you want to, if people need to get in touch with you or want to get in touch with you, what's the best way to do that?
The website is xndev.com, and if you xndev.com, and there you can learn about us, and there's a contact us form, and I'm pretty sure it has our email address. If you don't want to fill out the form, you can just just send it. I'm Matt@xndev.com. Justin is Justin@xndev.com.
Yep, we're both on the Twitters too.
Yeah, and if you can't watch the replay, go to the first screen and Google search our names because you can't spell it, that's fine too.
All right. All right, guys. Well, thanks so much for joining us. Great session. Thank you to everyone who came out. Watch for a link that's going to come to your email inbox to watch the on-demand replay. So everyone, stick around, take the survey. But thank you again from QASymphony. Take care.